Today we're going to start talking about proofs, looking at some of the reasoning that we've talked about before, and look how to write them into proofs. We're going to talk about a couple different types of proofs, but today specifically we're going to talk about two-column proofs. To start, I would like you guys to go ahead and attempt this warm-up on your own. So draw it and try to solve this warm-up. Okay, based on the diagram, or I'm sorry, the information, we need to be able to set up the problem like this. So we get that the two inside angles are going to add together and equal the outside angle there. And then when I bring everything to one side and set it equal to 0, I'm going to get two values for x. When I plug in my x values though, 2 is not going to work because when I plug in 2 down here, 4 minus 4 gives me an angle of 0. That's not possible, so I'm going to cross out 2. So when I plug in 6 in both cases, I'm going to get the measure of angle O and P is 24 degrees. So today we're going to look at proving statements regarding segments and angles, specifically how to write them in the two-column proofs, and specifically looking at using the addition and subtraction properties. So addition is going to be something where we're given a smaller angle and we're going to something bigger. So when we look at the two separate diagrams here, in this first one, we are given that PQ is congruent to RS. There are other segments that I can say are congruent because there are segments that share the overlap of QR. So I could say that PR is congruent to QS as well, because the smaller segments were congruent and they have an overlap there. So it doesn't matter how long QR is, if I'm adding the same thing, then it's going to be, the bigger ones are going to be congruent as well. Same thing over here on the right with the angles. I have a shared angle there in the middle. So if those little angles are congruent, I can say the bigger ones are congruent as well because I'm adding the same measurement. So angle BAD would be congruent to angle EAC. Similar concept, except not adding the same thing, adding the same measure though. So I have two segments that are marked congruent there. I have another pair of segments that are congruent marked there. So if I have two things that are congruent and I add them together, then their whole things must be congruent. Same thing with angles. Angles marked congruent. Angles marked congruent. So when I combine those congruent pairs of angles, I'm going to get bigger congruent angles. Angle TWX is congruent to angle TXW. Next two examples are going to go in the exact opposite direction. So I'm starting with the bigger segments or angles, and I'm going to get smaller, which is letting me know that I'm using the subtraction property. So in this case, I have the bigger segments are marked congruent, and they have an overlap. If I get rid of the overlap, so I subtract that from the bigger segments, then I'm going to be left with AB and CD are congruent. Same concept with the angles. I have the bigger angles are congruent, and I'm going to get rid of the overlapped angle there in the middle, which would tell me that angle EFG is congruent to angle JFH. Notice the key is that I'm starting with bigger angles or bigger segments, and I'm getting to smaller ones in each of these. Same concept here, except I'm not subtracting the same thing. So on the left side here, I have the whole segment and a smaller one. On the right side, it's congruent to the whole segment and the smaller one. So if I subtract the smaller one on both sides from the bigger one, I would be left with a smaller one on each side, KN congruent to KR, and then same concept over here with the angles, big angle on each side, subtract the smaller one, so I'm left with the little angle on each side. Make sure we're naming our angles correctly. Now we need to list all of those things in our proofs. So there's going to be a few different things that are going to come up in our proofs. When we are getting rid of or adding that same segment, we're going to need to state that. And why is anything congruent to itself? Well, that's just obvious, but we call that the reflexive property. If I were to reverse something, it would just flip the order. It would be called the symmetric property. And then the transitive is similar to the chain rule. When I say AB is congruent to CD and then CD is congruent to EF, so I've connected it with CD, then I can just say the first one, AB, is congruent to EF. And the same thing applies with angles. So then based off of that, go ahead and take a second and name these three properties. We would have the reflexive property, the transitive property, and the symmetric property. These are properties that we are going to use in proofs, so you need to understand which property is which. So how do we write these then in proofs? So we're going to continue to learn all these different theorems. We've talked about some already with right angles and supplementary angles and complementary angles. But we're going to talk about how to write all these things in proofs. We've now talked about how to add things, the reflexive property. All of these things are going to appear. And all of those things that we've stated are reasons. And they're going to come over here on this right side. So any reason that we've come up with, you have to, whenever you state something is true, you want to say these angles are equal to each other, these angles are congruent to each other, or whatever. You need to have a reason over here on the right side that goes with it. You also must be numbering your proofs all the time. Notice how every statement has a number and it aligns with a reason over there. You must always have statements and reasons aligning together. So this is a format of your proof all the time. You're going to have a given and a prove section, and then you're going to have a diagram section. So first off, let's format our proof the same way. Statements, reasons. So let's go with our first given statement there. Number one, B is the midpoint of AC. The reason why I get to state that is because it gave it to me. What does that, we got to think about what does midpoint tell us? Midpoint tells us that it splits the segment into two congruent segments. So I get to say then, we've already talked about midpoint. AB is congruent to BC. And my reason is midpoint implies two congruent segments. So we're using the definition of midpoint in order to say that. Our next one says C is the midpoint. So I say that because it is given. And then if C is the midpoint of BD, then I get to say those two segments are congruent because it splits BD up into two congruent segments. And it's the same reason here. Midpoint implies that I have two congruent segments. Now, looking at my statements and what I'm trying to prove, I want to prove that AB is congruent to CD. Well, I have AB here and I have CD listed here. They are both connected to BC. So if we recall the properties that we just went over up at the top, I get to say that AB is congruent to CD, and that is because of the transitive property, because they are both connected by BC. Now, because I'm using multiple steps, not just the previous one, I'm using multiple steps here. The two steps that I'm using for the transitive property are steps 2 and 4, so I need to list those in parentheses. For number 2, again, let's start off our statements and reasons. And then label our given and then start there. ADC is congruent to BDE. And then I want to get to ADE and BDC. This is just like up at the beginning. This is one of those examples that the only difference between the purple angle that I drew and that yellow highlighted angle is the fact that there is an overlap in the middle of this angle. So I need to bring that angle into the problem by saying that angle ADB is equal to angle ADB. And I know that's obvious, but I need to incorporate that into the proof in order to use that. Now, this is again one of those properties we just went over. The reason why those two angles are congruent is because of the reflexive property. Now, that purple angle plus the reflexive angle on the left, and then the purple angle and the reflexive angle on the right can combine together. So I am adding two things together. And this is, I'm adding the same angle, so this is same angle addition. That's the property I'm using. And I added steps 1 and 2 together to give me step 3. We're going to go over number 3 together in class, but I would like you to do number 4 on your own. So complete number 4. right now prior to class.